we're going to discuss your problem, then we are going to start our next topic. So can you please let me know what is your doubt?
So actually, I wanted to ask when to know how to use Markov-Nikov rule or anti-Markov-Nikov rule, because both of them convert alkene into like alkane, right?
Yeah, it's very easy. As you know that basically, if any alkene is given and you are going to treat it with HX, and generally you will see this HX will be generally HBr or HI or HCl, not HF. So if there is an asymmetrical alkene, you know, this is asymmetrical because if you are going to divide it from here, you will see on the left hand side there will be something else, and on the right hand side there will be the two groups that is divided into two parts are not equal, that is asymmetrical. So in this asymmetrical alkene, this Markovnikovs apply. Okay, because in symmetrical alkene, if you are going to apply the Markovnikov, it won't work whether you are going to add this HBr, whether you are going to add Br to this carbon or this carbon, it will be same. So that's why we don't apply this Markovnikov or anti-Markovnikov in symmetrical alkene. So see, if you are going to add HBr, only HBr, then it will be treated as Markovnikov. Are you getting my point? And you know what is Markovnikov? Negative part of this addendum, you know which one will be negative, H will be positive and Br will be negative, yes or no?
Yeah.
So this negative will go to that carbon which has lesser number of hydrogen, and positive will go to that carbon which has greater number of hydrogen. So this is how you are going to recognize an alkene added in HBr in presence, in absence of peroxide. In absence of peroxide, it will be written that alkene plus HBr, then it is Markovnikov. And if it is written as CH3, CH double bond CH2, and you are going to add HBr in the presence of peroxide, if peroxide is there, or it will be written in presence of peroxide, then it will be treated as it is anti-Markovnikov. Are you getting my point? Either it will be written peroxide or either it will be written in presence of peroxide, then anti-Markovnikov will apply. And what is anti-Markovnikov? Negative part will go to that carbon which has greater number of hydrogen, and positive part will go to that carbon which has lesser number of hydrogen. In Markovnikov, only this and this will be given, or else it will be written in the absence of peroxide. Okay.
Yeah.
So do you, have you got it? Or have you understood it?
Yeah.
Okay. So do you have any other doubt in this chapter?
No.
Good. So can we start our topic? Or let me know if you have any other doubt other than this Markovnikov. If you have got it, then we can move to the next. Please do let me know. Firaz, can we move to the next part?
Yes.
Okay. So let's see. As you can see that we were done with this oxidation part, right? We were done with this oxidation part. We did oxidation of alcohol and we got benzoquinone. Now there are some portion that you need to study first, and then I will give notes on that if it is required. There is a topic that is some commercially important alcohols, So you are going to read about this today, and let me ask me whatever is your doubt in this topic. It is basically methanol, ethanol. This you are going to study the theoretical part, so you can do this by on your own, right? Can you do this?
Yeah.
Basically, in this topic, you will see how we are going to prepare methanol. And basically, this methanol will be prepared. You are going to react this carbon monoxide in the presence of hydrogen. You are going to react this carbon monoxide with hydrogen, dihydrogen, in the presence of ZNO, Cr2O3 at 200 to 300 atm pressure. The pressure should be this, and very high temperature like 573 to 673 Kelvin. Then you will be getting CH3O, and you need to study the uses of this methanol. And again, there is ethanol that you need to study. So can we move directly to ether, because this is the last topic for alcohols and phenols. Please do let me know.
Yeah. Yes, sir.
Thank you. Now see, let's start our ethers, and we are going to see the methods of preparation of ethers. Methods of preparation of ethers, and there are two methods to prepare ether. The first one is basically by dehydration of alcohol. This topic we have already covered, dehydration of alcohols. If you are going to do dehydration of alcohols, you will get alkene. We have studied this, but here by dehydration of alcohol, if you are going to change the condition, then you will be getting ether. So I'm going to show both the reaction that we have studied. One of the reaction that we have already covered, and you are having an alcohol that is ethanol. And if you are going to react this with H2SO4 at 443 Kelvin, then H2SO4 is basically dehydrating reagent. That means it will eliminate water. So OH from here and hydrogen from here will be eliminated, and you will be getting ethene as main product. But if you are going to react the same reactant ethanol with H2SO4 and at 413 Kelvin, 30 degree centigrade lesser than this, then you will be getting C2H5O. That means ethoxyethane you will get. How you will get this ethoxyethane? We will talk about it. I'll show you the mechanism. It's very easy. First write it and then let. Let me know when you are done with this.
Yes.
Can I change the slide? Firaz?
Yeah.
Okay. Now see, the mechanism is in 3 steps. So this is your ethanol, and you know oxygen will have 2 lone pair, and since it is dipped in water, basically H2SO4, that means acid, so there will be H plus. So since this is proton and as you can see there is no electron, so this will attack on H plus and it will be forming CH3, CH2, and then oh, hydrogen was already there and this hydrogen will come here and oxygen will have positive charge because it donated one of its electron to H plus. Is that clear? Is the first step clear?
Yeah.
Now, in the second step, we are going to again take the mole, 1 mole of this, another mole of CH3, CH2, OH. As you can see, this is the scenario, and I'm going to take this. So there will be CH3, and then there will be CH2, and then there is O plus, O positive, O plus positive, and there is 2 hydrogen. Now, as I already told you in the previous chapters and lectures, that on positive charge on oxygen is very less stable, very less stable. Are you getting my point? The one which is
Yes.
more electronegative, then negative charge on that electronegative element is more stable, but positive charge is very less stable. So what it will do, oxygen will take electron from carbon to stabilize itself and it will be eliminated in the form of H2. Now, since oxygen took the electron of carbon, carbon will have deficiency of electron. So this will attack on carbon to satisfy carbon's bond. So I'm going to write this part first. So there is CH3 and there is CH2. And as you can see, this O, then as you can see, this oxygen basically attacked on this carbon. So there will be O and hydrogen is already there. And since oxygen donated one of its electron to carbon, so there will be positive. And on the left hand side of this oxygen, there was CH2 as well as CH3. Are you getting my point? I'm going to erase it and again write it. There will be CH2 and there will be CH3 and H2 was eliminated. Now, as you can see, again oxygen has positive charge and oxygen positive charge on oxygen is very unstable. So it will take electron from hydrogen to stabilize itself. So I'm going to write it in the third step. This is CH3, CH2, and there is O and hydrogen. There is positive charge on O, and then CH2, and then CH3. Positive charge on oxygen is very less stable. So what it will do, it will take electron from hydrogen, and hydrogen will be now again proton. So the product formed is, you can see, is ether. In this way, ether preparation took place, or else you can write C2H5O, C2H5. Is that clear?
Yes.
Please do write it. Let me know when you are done with this. Let me know when you are done with this. Are you done with this, Firaz?
Yeah.
Okay. Now the second preparation, only two preparation you have to study. The second preparation is quite famous, and it is your Williamson synthesis. Williamson synthesis. So see, Williamson synthesis. If you're going to react an alkyl halide with a salt, that is sodium alkoxide. Sodium alkoxide. There will be negative charge here. This is your sodium alkoxide, and this is your alkyl halide. Sodium alkoxide is basically a salt. Now you can see what will happen. This will have negative, this will have positive. So negative will go with positive. So what it will form? It will form ROR, and salt NaX will be the byproduct. Are you getting my point? If you have CH3 Br and you are going to react this with CH3 O negative and Na, then what you will be getting? You will be getting as a byproduct NaBr, and you will be getting methoxy methane. Is that clear?
Yeah.
No. This is very important to know that. Please do let me know the product of this. And it's a very important. Please do this.
NaBr will be separated.
Yeah, that is byproduct that we don't need to focus.
So CH3 attached with
By,
C.
yeah, this is basically CH3, CCH3, and then there will be CH3, and this is your O, and then CH3. It will be attaching with, as you can see, this will have positive and this will have negative. So this positive will go with oxygen, so it will form an ether. Are you getting my point?
Yeah.
So can I change the slide?
Yes.
Okay. Now tell me about this. What is the main? Are you done with this? See, Firaz, it's a very important concept that you can see this is your tertiary, what we can say, tertiary ether. Whenever there will be primary alkyl halide, the product will be this. Substitution will take place. Someone will take someone's place. But whenever there will be tertiary alkyl halide, am I audible clearly?
Yeah. Elimination
Then
takes place.
elimination competes over substitution. Elimination competes over substitution. So as you can see, elimination is taking over substitution. So this Br and one of the hydrogen from here will be eliminated. So what it will be formed, CH3C, and this CH3, I'm going to write it on the right hand side. And then there will be, this is your CH3, double bond CH2. Now where will this H go? H will be eliminated in the form of H plus. So H plus will go with this O minus and it will form methanol CH3OH. And Na is positive and Br removed in the form of Br minus. So there will be NaBr. Is that clear?
Yeah.
Okay. Can I change this? Let me know when you are done with this. Are you done with this, Firaz?
Yeah.
Okay. Let's see. Phenols basically also react in the same manner. So phenols are also converted to ethers by this method. And you can see this is your phenol. And if you are going to react this with NaOH, you will be getting phenoxide ion. This reaction we have already discussed in previous lectures. So it will be ONA, which will have positive and it will have negative. And if you are going to react this with RX, alkyl halide, this will be negative, this will be positive. So this will go with this and it will be forming an ethers. Got this? Please do write. Please do let me know when you are done with this. Firaz. Done. Okay. Let's just start our chemical reaction of this phenol. So write the topic, chemical reactions. So are you able to solve all the question from NCERT? Yes or no? As I already told you to do all the NCERT questions, exercise as well as in text, solved and unsolved. Did you do that?
Yes.
So let's start our chemical reaction with the cleavage of CO bond in ethers. So the first reaction you are going to do, this is your ROR, and you are going to react with HX. So there will be cleavage of CO bond like this. You can cleave any one of them, and you are going to cleave this part, and you can see this is positive, this is negative, this is positive, this is negative. So this positive will go here, and you will be getting an alcohol, and then you can see again this negative will go with this. So it will form RX. And if you are having this RX, again you can react this alcohol. You can react this alcohol. If you are this this HX in excess, then you can again react this. And again you can write this, since we are studying the cleavage of CO bond. So negative and then positive and then negative. This positive will go with this, and it will form H2O. And then again you can see this negative and positive combine to form RX. This second reaction only occur when this HX will be in excess or at least 2 moles. Are you getting my point? Then the next product will be again RX, alkyl halide. Okay. So in the same way, you can go for this reaction as well. So if this is your ether, you can see, and you are going to react with only 1 mole of HX, only 1 mole of HX, then what you will be getting? You are going to react cleaved this as well as this. So this positive will go to this, and you will be getting a phenol. And this is your RX, alkyl halide. So please do write it. Let me know when you are done with this. Let me know when you are done with this, Firaz.
Yes, sir.
Okay. Now, it's very important, as you know that iodine is the best living group. So the order of reactivity. Order of reactivity of hydrogen halides is basically hydrogen halide. We are going to talk about hydrogen halide. So it will be hydrogen iodide greater than hydrogen bromide greater than HC. This is the order of reactivity of hydrogen. Please do that. And also please do this reaction. I think you can do this.
I is going to bond with C.
I will go with C.
C.
So basically there is a yeah, it will be basically the product will be
CH3OH.
like this. Yeah, the byproduct is basically alcohol, right? This is the product that you have got.
Yeah.
So basically in mechanism, basically there is a formation of carbocation. There is formation of carbocation. So how the reaction took place? You can see this is your CH3. Wait a minute. Is my video lagging? Yes or no? Because is my video lagging? Since the reaction took place in acid HI, so H plus will come here and it will react with basically oxygen will bond with hydrogen H plus and there will be positive charge and this step is basically slow. It's the mechanism you can see and this will be basically CH3 and then C plus and then there will be CH3 as well as there will be CH3. How this carbocation took place. So in order to satisfy itself, oxygen will take electron from carbon and there will be formation of carbocation and now it will be CH3. Now as you can see, this is your carbocation. This is your carbocation. So what it will do? It will be attacked by ion negative. So CH3, CH3 and positive is there, carbocation. So iodine will come and it will attack on C positive and what is formed, it will form the product that you have said. Please do that. Let me know when you are done with this.
Done.
No. Let's just start the next chemical reaction, that is electrophilic substitution. Electrophilic substitution. So can you tell me this ether will have plus or effect, positive resonance or negative resonance? Can you tell me? Positive or negative? Am I audible? It's not working. Are you there? Firaz,
Yeah.
can you draw the resonating structure of this ether? Can you do the resonating structure of this or not?
Yes.
The ether has plus R effect. So what it will do, it will donate electron and it will be like this. So
Yeah.
I'm going to write the resonating structure. You can see there will be negative charge and then there is double bond O R. And then there is double bond as it is, there is double bond. Since oxygen donated electron, it will have positive charge. Now again, this will move like this and this will move like this. Now, as you can see, the negative charge on para now, the negative charge on para and the double bond moves here and the next double bond as it is and this is as it is OR positive. Now again, this will move to this, so it will move to hit this point and then the negative charge will come toward and then there is O double bond OR positive. And then again, the negative charge will move like this and this. So this is your basically resonating structure of this ether. Double bond, double bond, double bond. So please do write this resonating structure of this. Methoxybenzene, alkoxybenzene, you can say. Let me know when you are done with this. Are you done with this, Firaz?
Yeah.
Now see, this is the resonating structure of alkoxybenzene, and now we are going to study halogenation. That means addition of halogen will take place. So it's very easy. We have already studied this reaction. So this is your ether that I'm going to write. And you are going to react this with Br2 in ethanoic acid. Ethanoic acid. So Br will be substituted. Br will be substituted at ortho as well as para. At ortho as well as para. So this is your ortho and this is your para. Can you tell me which one is more stable or which one is more? Now, which one is major and which one is
Parallel.
more stable? Oh, wait a minute. Let me tell you this. Put this with it. CS3, methoxybenzene. We are doing this reaction for methoxybenzene especially. You can write. You can also write R. That is not a big deal. So this is your para is your measure. This is your major product, and this is your minor product. Please do write it. Is my video lagging, Firaz?
No.
Okay. Please do it and let me know when you're done with this. Please do let me know when you are done with this, please. Are you done with this? Firaz?
Yeah.
Okay. After halogenation, we have Friedel-Crafts reaction, and Friedel-Crafts reaction is of two types: Friedel-Crafts alkylation and Friedel-Crafts acylation. Friedel Friedel-Crafts reaction. So one is alkylation, in which what we do, anisole, that means methoxybenzene. You can see this is your anisole. The common name of methoxybenzene is anisole. And if you are going to react this anisole with CH3Cl, chloromethane in the presence of anhydride AlCl, anhydride AlCl3 and CS2 carbon disulfide, then methyl group will be added at ortho and para as well. So this is your ortho position, OCH3, and this is your para position, OCH3, and you know which one is more stable or major product is your basically para. And this is especially known as to be more specific. This is your Friedel-Crafts alkylation because alkyl group added. Friedel-Crafts alkylation. And for Friedel-Crafts acylation, that means acyl group will be added. Anisole will be reacting with acyl halide. This is your anisole reacting with CH3 COCl in the presence of anhydride AlCl3. Anhydride AlCl3. Then you will be getting acyl, addition of acyl will take place or ketone will form. This will be as it is. And then this will be COCH3 at ortho as well as at para. And this is your known as Friedel-Crafts acylation. Friedel-Crafts acylation. Please do let me know when you are done with this. No, let me know when you are done with this. Firaz, are you done with this?
Yes.
No. Now the last reaction of this electrophilic substitution reaction in this chapter is nitration. That means nitro group we are going to add. Nitration. So NiSO. So this is your OCH3, and you are going to react this with H2SO4. Basically HNO3 in the presence of H2SO4. There will be generation of NO2 plus electrophile that will attack on this benzene, and it will be converted into nitro anisole. You can say nitro will be at ortho as well as para. Please do that. And you know which one is major. Para is major and ortho is minor. So this will be your minor and this will be your major. Please do write it. My printer is not working. Are you done with this?
Yeah.
So the chapter is completed here. Now I'm going to give you some question. Please go right. So do you have any doubt from this chapter in any concept or any question? Which one of the following has the highest dipole? So write with me. CH2 CH. CH3 and CCA. Please do that. Are you done with this?
CCl4?
CCl4 has a mu that is equal to 0. To understand this in 2D, I'm going to draw a diagram like this, CCl4, to make you understand only. So as you know, chlorine is more electronegative. So it will attract electrons and like this and like this. My pen tab is already not working. Okay, so please. Sorry. Firaz, you can see this is both are in opposite directions, so they will cancel each other. As well as you can see this both are in opposite directions, so mu here it will be equal. Are you getting my point? Now see CaCl3.
Yeah.
So this is your hydrogen, and this is your chlorine, and this is your chlorine, as well as this is your chlorine. So as you can see, chlorine is more electronegative than carbon. So this is the situation, and you can see this both will cancel each other's effect. But carbon is more electronegative. These two are in both directions, same direction. When you are going to talk about this CH2Cl2, I'm going to take this situation CHH and then chlorine and then chlorine. Now you can see that this will is like this and this is like this. So they will have they are in same direction, two of them, and there will be a resultant vector like this. So it will have the most, then this, and then this. It has a value 0. Is that clear?
Yeah.
Very good. Now, the next question. Wait a minute. Can you react this one bromo, one methyl, cyclohexane by dehydrohalogenation? Dehydrohalogenation. That means you are going to remove this hydrogen and bromine. What is the name of alkene that will form? Can you do this? Wait a minute. Tell me the IUPAC name of this alkene. Let me know the name of the product, the major product you need to tell me. Major product. Okay. Let me know when you are done with this. Can you do this? We did this reaction in presence of alcoholic KOH or heat, then dehydrohalogenation will take place. Russ, please do let me know when you are able to, if you are able to solve it or not.
One bromomethyl X2 in.
Let me draw the structure first. This is your cyclohexane, the parent chain I'm going to write, parent cyclogen. One methyl, one bromine. That means this is your CH3 and this is your B unit. This is your B unit. So as you can see, there will be the elimination of this is your alpha carbon, and from beta hydrogen goes, and this is your beta, this is your beta, this is your beta. So if you are going to remove hydrogen from here or here, it will be same. So there are two products that you need to prepare. You are going to remove hydrogen from here and bromine from here, you will be getting this product. And if you are going to remove hydrogen, beta hydrogen from here and bromine from here, you will be getting this product. Can you tell me which one is more stable? Which one is more stable?
Double bond.
Double bond is there. Both here is also double bond and here it is also double bond. So this is more stable, A or B? Which one is major
A.
product? A is major product. Very good. Now one more question I want to ask you from this chapter. Can you convert this ethane into bromoethane? No, bromoethene. Can you convert this ethane into bromoethene? Can you do this?
Yeah.
No, please do.
So, sir, first we have to do BR2 and UV light under the presence ethane.
Very good. That means you are going to react with this Br2, right?
Yeah,
And you will be getting bromoethane, right?
yeah.
So after this,
Then dehydrohalogenation with HBr and KOH.
dehydrogenation, then you will be getting CH2 double bond CH2, right?
Yeah,
And after this, you are going to do Br2 in the
BR2
presence of
CCl4.
CCl4, right?
Yeah.
So what you will be getting
Then again
CH2,
halogenation.
CH2, and then Br here as well as Br, right? Vicinal dihalide, and then
Yeah.
alcoholic KOH again, dehydrohalogenation, that it will be CH2 double bond CHBr. So this is how you prepare it. Okay. So this